Alright, here we have permutations and combinations. So some of these problems will denote right off the bat if you're dealing with a permutation or combination, but many of them will not. So you'll need to be able to identify from the problem which type you are working with. So for number one, we have how many different 5-letter words, in quotations because they might not actually be words, can be formed if each letter has to be unique in that said word. So if we're dealing with 5-letter words, quote unquote, they may not actually be words. We would have a couple different ways you could set this up. So one way, because the letters do make different words if you arrange them differently, would be a permutation, 26p5. That's how you can write it if you're dealing with a permutation there. And if we were writing it out with the permutation, we'd have 26 factorial over, and then in parentheses, the 26 minus 5, close the parentheses, and then factorial. So make sure you do subtract those first before you do the factorial. You cannot distribute the factorial sign into the parentheses. You do have to do the parentheses first for these. So here, if we go through and do that, we'd get 7,893,600. Or like I said, this one you could do a slightly different way. Since once again, we know that each one has to be unique and we are arranging letters. So another way you could have done this, since there are 26 letters in the alphabet, is that the first letter has 26 possibilities. The next one has 25. And then you could keep going down each time, because whichever letter you already used, you cannot use again for the next one. And we could do that until we have all 5 letters for our word. And if you go through and multiply those together, you should get the same answer there. So some of these you might be able to do a couple different ways depending on the problem. So that would be one way of going through and picking for this 5-letter word if each of the letters has to be unique. Unique means that they can't be the same as one that already occurred. If you did not have that unique part, then it would just be 26 times 26 times 26 until you had all 5 letters of the word. Or in other words, it'd be 26 to the 5th power if it was with not unique. Or in other words, that they could be the same. So it does make a difference if it says that or not. So if it's not unique, then you do 26 to the 5th power instead. So for number 2, how many ways can a committee of 3 people be selected from a group of 10 people? So we've just got a committee being selected. There's no specific way they're being picked. They're not being selected for any specific position or anything else. So here we'd have a combination. So we'd have 10, C3. Always has to be the bigger number in front and the smaller number behind the C. Otherwise, you're going to get the incorrect answer there. You're going to always get the same answer, in fact, or your calculator may give you an error depending on how it's programmed. And then make sure that you do know the formulas as well. So here we'd have 10 factorial over. And then remember, do these separately if you're going through and doing this in your calculator. The top and the bottom separately there. Some of you may be able to do it all at once depending on how yours is programmed. If you are trying to enter this all at once with the factorials, you are going to need an extra set of parentheses around this bottom, around the denominator there. And for this one, you should end up with 120 for your number of ways of selecting a committee of 3 if you had 10 people to choose from. So there's normally a lot more possibilities than you may think for these types of problems. And then for number 3, how many different ways can a committee of 3 people be selected from a group of 10? So the first part starts out exactly the same as number 2, but in this case we have if this committee consists of a president, vice president, and secretary. So they're each getting put into a different position. So if someone's picked as president, that's different than if they're being picked as vice president or secretary. So there is a difference there between each of those positions, or how they are selected. So in this case, it would be a permutation instead of a combination here. But you'd still have the 10 and the 3. But remember, for the permutation, you're always going to have more possibilities because your arrangement of those makes a difference. Whereas combinations, no matter which way you pick it, whatever order you have it in doesn't make a difference. Permutations where the order matters. So you are going to have more possibilities. So here you'd have 720 possibilities. So way more possibilities if they're being picked for specific positions than without. So make sure, remember, permutations where the order matters, where they're being picked a certain way, and combinations is where order does not matter. If you do have questions on any of this stuff, make sure to ask like normal.